So just as a recap, so that we're all still on the same page here, right now we're working on the density volumes that are going to be sourced into the main pyro simulation. We're working with Axiom right now. We have this guy. I don't like how we have this big chunk right there, so we're going to make that more of a linear fall off. But in general, I do like how it's spreading across the ground and we're getting something that's detailed and interesting out of that. Also, our disturbance is way too high, and really at this point, it's about dialing in something that looks nice and interesting for that density source. Okay, so starting with the fall off, let's go to our volume slice real quick. Find a good frame, maybe right about there, and adjust this ramp so that we're going more so like this. And it's okay if we maybe have a little bit of a higher lead in like so, but I would like to again make that more linear to get rid of that weird fall off that was happening before. Okay, so that's good. Also on our velocity, we can do something a bit more interesting than this, and while we're at it, we're getting to pretty much 0 over here. So one more thing on this ramp, let's give ourselves at least a little bit of velocity on these guys so that they get off the ground. Okay, much better. But like I was saying, we can have some more interesting movement in general. If we go back to this guy, it's just kind of flat, boring, not really interesting looking. What we could do is we could alter those values based on deformed points which exist above the original bed of points. And so if we take, let's say, the version of the points down here, right? We deform them along their normals in, let's say, that direction, and we use a noise to generate how high they are. We can use that change in position to affect another velocity. And what I'm trying to do with that is take this whole flat shape and break it up so that we end up with something a bit more like that. And so anyway, this will make sense here in a minute. But we're adding another velocity is what we're doing. So with that point velocity, let's go back here. And I'm going to use a mountain sop. This mountain sop is cool because we can say do not center noise, and that'll just lift everything up like this along their normals. And like I said, we can take the difference in positions and use that to add into our existing velocity. So if we go maybe add a bit of roughness to that, I like using a whirly cellular F2, F1 noise right here, or maybe just F1 actually. If we do that and we increase the element size, so we go something around here with that. The original points are down here. This is the deformed points. Certain areas are going to get more velocity now. Again, that'll break up that boring shape along here. So if we use a point wrangle, we can simply take our existing points over here, the deformed points, and we could say this. First of all, sample the position of the mountain points. So vector mountain points is equal to our point function. Go through inputs number 1, that's our second inputs. So right along here, look for position and use point number to match up the point values. The velocity that we're trying to generate is going to exist as a vector as well. And let's call this whole thing our mountain velocity. And that's going to be equal to our current position minus the position we found in the mountain points. Now, just to be sure that we have this facing the right way, what happens when we set our current velocity to the mountain vel? Let's be sure that they're pointing in the right direction real quick. And let's see here. There we go. Go for mountain points. Okay, and as soon as that happens, it looks like we are facing the opposite direction. So we need to take mountain points minus our current position. It's always difficult to remember which order that goes in. But now we're facing in the correct direction. Okay, but we're not trying to just change our current velocity with just that value. We're trying to, let's say, add that in to what it currently is. So let's just say plus equals the mountain vel. Now, this mountain vel needs to be turned up in scale, so let's add that whole calculation in parentheses times a channel vector called our mountain vel scale. We'll go like this, and now as we turn this up, as you can see, we are influencing that original velocity, like so. Okay, that's pretty awesome. Now, let's plug this all back in. So we're going to call this wrangle our mountain velocity, and this guy is going to be our velocity mask. That gives us a situation like this, where we have a combination of the curl noise, the direction based on our normal, and now this mountain velocity. And we can also change the intensity, by the way, by turning up this height. So if we go like that, you can see those vectors are now moving as well. Let's see what that does in our PopNet. So after doing all that, we end up with this. It looks pretty good in general. I think perhaps we could make our mountain noise a bit more influential. We're still kind of getting everything going up to the same degree in the middle there. Also, you can add mass to the particles. That will change, obviously, how heavy some of these guys are. That means some particles will be affected less by drag than others. And so I think at this point, it's a lot of detailed tweaking. But what I've done is I've turned off ignore mass for the pop force, for the pop drag, and now we have an attribute randomize set to mass. That's between 0.5 and 2 for every source particle going in. After doing that, we do have a slightly better distribution of things going on. And again, to go back up here to the point velocity, let's take our scale here down to 5, leave that at 2, and turn up our mountain velocity a bit more right here as well. Let's see what this does now. Okay, now we end up with this. Going to bring back a little bit more of that velocity from our normal, but I do like where this is heading in general. So at this point, it's really about taking a few back and forth trips and dialing in the right settings, but the overall setup is there. And I think that with the combination of all those things, it should be enough to give us something interesting on the axiom side of things. So in the next video, we're going to finish that and then move on to something else.